This is weird, right? Having to do this online. I was hoping to have to or to get to do this in a classroom. Um, just to start off, I know it's kind of frustrating watching the videos sometimes, and when you're stuck on something, not getting any help like right away for it. But just know that you can email me anytime if you want to take a picture of the stuff that you're working on and send me that picture. I can try and figure out what your mistake is. Um, or if you have like a homework question that you're really confused on, um, I'm I'm up for just making videos just answering specific homework questions and uploading it to Moodle, so I can do that too. Um, I guess I should introduce myself. So my name's Tyler. You can just call me Tyler. It's fine, right? We're informal this semester. Um, Let me share my screen here and just to kind of go through the class. I want to make sure this works. Is everybody seeing my screen all right? If you guys just want to chat and give me a yes. Yay. Okay, great. Thanks. This is on the Moodle page. There is a bunch of issues for you guys, especially because I know some of you were signed up for the Newbern course. Others were signed up for the Havelock course, and then you were all kind of combined together into this online Havelock course. So I hope everybody is entered into the right course here in Moodle, the 272 HW1. And I haven't checked to see who has and hasn't completed the syllabus quiz yet, but this needs to get done by tomorrow. So if you have not finished the syllabus quiz, you have to go and take it by tomorrow. Otherwise, the school is going to drop you from the course. So make sure you get that done if you haven't done that already. Other than that, just kind of play around here with these different links. Definitely look through the syllabus and read through that. I would also recommend looking through this formula sheet, and if you have a printer, printing it out and having it with you and beside you as you work through the material. I think I'm going to stick with the schedule that I have for now. Tuesday nights at 6 and then Thursdays at 1 p.m. For these meetings, but if that needs to change, then I'll change it up and we'll kind of see what's going on. Other than that, though, just to kind of jump into the material, because you do have stuff due this Sunday, Chapter 6, Sections 1 through 4. I hope you all have already started looking through these videos that I've posted up here. So I have 5 videos just for Section 1. It was a huge section. And then Section 2, Section 3, and Section 4 were all just 1 videos each. Unfortunately, that's just going to have to be the way that you guys learn the material here, is watching through these videos that I make. I try to make them about the same caliber as if I was teaching in a classroom, but it's just hard to do over the internet and making videos. But there they are. Please watch through these and take notes with them. Try the problems that I'm working through on your own to make sure it's making sense for you. And then from there, moving over into the course here, if it works for me. Has anybody had any issues with MyLabs Plus and the course showing up for you and getting signed into it using the access code? Is there any questions with that? I always assume that in Calc 2 everybody has already taken a math class at Craven, but I guess that's not 100% true. So if you have not taken a math class at Craven, just follow the instructions that I had emailed out. I think it was like a few days ago. But any questions about this? Is everybody in the homework website here? All right, great. The 10-second feedback loop is going to be annoying. Okay, so once you're on the website, just in case some of you have not worked through this website before, all of your tabs are here on the left. The course home, the syllabus, any homework or quizzes are going to be over here. The grade book, of course, is whatever the grade is in the grade book at any given time is your official grade. So always make sure you're checking that to see how you're doing. And then the other thing is that if you don't have a physical copy of the book, if you go down here to this chapter contents button, we're starting in chapter 6, section 1, right? It has this e-text. So if you don't have a physical copy of the book, it's not that big of a deal because you can always open up this PDF here. Well, when it works, you can open this up. I remember in the past that anytime I'm using WebEx, I can't open up the book at the same time for whatever reason, but it usually works. So anyway, you have a copy of the book there. As far as what these meetings are going to be, these meetings ideally is just going to be for you all to ask questions that you're struggling with on the homeworks. I know your homework isn't due until Sundays, which for most students is put off until Saturday night or Sunday night even. But I implore you to please try to work ahead and work on the problems throughout the week. That way, if you do run into issues with the homeworks, you can ask questions here in these meetings leading up to the homeworks. I will always try to have the homeworks up and ready at least a week in advance. So for now, right, you have the sections 1 through 4 that are due this Sunday, but I've gone ahead and put up section 5 and 6 due for the week after that. We're going to be finishing up chapter 6 in that week, which means the chapter 6 test is coming up already here in a few weeks. So make sure you're watching the videos in Moodle, going through the homeworks, reading through the book, and keeping up with the assignments. Because if you fall behind, it's going to be a real struggle, right? This class is already condensed down because it's a summer class where usually it's the full 16-week course. But on top of that, we're doing it online too, which means you're doing it at your own pace. So it's going to be hard, and it's going to be quite a bit of effort on your guys' part to make sure that you're keeping up with everything. All right, with all that being said, that was my big speech for the day. Is there any questions, not about the material yet, is there just any questions about the course in general? Whether it's quizzes, homeworks, tests, Moodle, anything?
Yeah, when I try to access my Lab Plus, it says that I need an access code. So where could I find that?
Right. So the access code is if you bought the book from the bookstore, the access code is just kind of saran wrapped to the book, and you just type that in. If you did not buy the book from the bookstore, then the only other way to get the access code is to purchase it directly from the website, which I know it sucks, but it's just something that you're going to have to do for this semester. So again, if you bought the book from the bookstore, it comes with an access code like in the book or attached to the back of the book. But if you're borrowing the book or if you bought the book used, you're just going to have to buy that access code from the website.
I bought the textbook, but it said something about like it was back ordered.
I did. Yeah, I wasn't sure if that was for Calc 2 as well. But I did hear that the bookstore is way behind on their shipments because of the coronavirus stuff. When you initially go into the MyLabs Plus, though, when it's asking you for that access code, there should be a button that says 2-week free trial. So you can at least hit that button and get 2 weeks for free, and then hopefully the book will be in the bookstore by the end of that 2 weeks.
Yeah, I tried that one time and it said error.
When you hit the 2-week free trial thing?
Yeah.
All right, that's not something I've heard of before. I just try it again. You know, sometimes if you wait a day and try it, it'll work out. And if that doesn't work, try a different browser. Like I know I usually use Chrome, but sometimes Internet Explorer works better with this, and sometimes Firefox works better. So if your browser is not really working out, just try a different one. That always seems to fix whatever issues you're having. If you're still having issues and it's still giving you an error when you hit that, email me tomorrow and let me know, and I'll contact Pearson myself and see if we can fix it. Any other questions about anything? Everybody else good? Okay, well, now let's jump into the actual material itself. So here's the homework page here. So I talked about this in the intro video, but I did put up this integral practice assignment. I don't know how long it's been since some of you have taken Calc 1, but even if you just took Calc 1, I still have students that struggle with integrals, mainly because integrals don't even show up until the last month of Calc 1 anyway. So I've put up this practice assignment. This has to do with stuff like U substitution and integrating cosines and sines and e's, that kind of stuff. So again, if you struggle with that, or if you feel like you need a little bit of extra practice, just pop into here and go through the view and examples and the help me solve this, and just to get some extra practice. To the material itself, I'm sure that most of you haven't gotten too far in the material since this is our first meeting here, and again, the homework's not due till Sunday. But are there any questions from this first section itself that you all want to look at together? Otherwise, I might pick some at random just for us to get some practice with together. Okay, I'm going to assume by the silence that we don't have any questions in particular, and I'm guessing that's because most of you haven't had a chance to even get into the homework yet, which is fine. So let's do this. We probably won't stay like the full hour today. Let's just do maybe 2 questions together, just so you can kind of get a head start and just see some of these problems worked out. So I'm just going to open one up until I find one that I really like. Don't really like that one. Here's an okay one. So let's look at this one. So we'll just kind of go through it real quick so you can kind of see it worked out. And like I said, just kind of for you to get some practice starting a problem and then working through it all the way to the end in one motion. Or at least to see me do that. So here, find the volume of the solid generated by revolving the shaded region about the x-axis. And then it's just asking for the volume, type an exact answer. So they give us the equation here of the line that borders our triangle area that we're revolving around. Now, I know most of you probably haven't gotten into the videos too much yet, but anytime you have a solid where you're making or you're creating it using revolution like this, you're going to be using something called the disk method or the washer method. For this question, this is question 3 on that homework, we're going to be using the disk method. There is a formula for the disk method. This comes from the book. It's on that formula sheet as well. The volume is the integral from a to b of pi, and then whatever the radius is as a function of x, all squared. Now, it could be a function of x or it could be a function of y. It just depends on which way you're doing your revolution. Because we're revolving around the x-axis, we're going to be derivating here with respect to x. All we need to do is we need to come up with this radius formula for our disks. So on our shape over here, we're going to be thinking about vertical slices of my area. With these vertical slices, when I revolve that slice around the x-axis, it creates a disk. The radius of that slice is just the height of the function at any x value as I go along the x-axis here. To find the height of the function, I have to have it solved for y, since y is the height. So we're just going to take this 4x plus 3y is equal to 24 and solve it for y. All right, not too bad, right? So subtracting the 24, or sorry, subtracting the 4x over. And then dividing everything there by 3. We get that, right? So y equals 8 minus 4/3 x. So because that is the height at any given x value, that is going to be the radius. So our radius is that function, 8 minus 4/3 x. Okay, and then other than that, you just plug it in. So then our volume is going to be the integral. The limits of my integral is going to be where the slices exist. So my vertical slices of this triangle exist from 0 to this intersection point right here, which I think is 6 just by looking at it. I mean, it's got to be. And then we're going to plug in, so pi, and then this radius, 8 minus 4/3 x, all squared dx. Okay, other than that, just multiply it out and then do the integral. So the integral we still have from 0 to 6. We still have the pi. We're going to have to FOIL this all out. So, first, outer, inner, last. So 8 times 8 is 64. My inner and my outer is going to be 8 times this negative 4/3 x, which is negative something, 32/3 x. And then there's 2 of those. So another negative 32/3 x. And then plus the negative 4/3 x times itself, which is 16/9 x squared. All right, I think I did my math right there. If you guys have a calculator with you, please check it. I'm the worst at not actually trying to do it in the calculator and trying to do it in my head. And I always mess it up. Combining like terms here. I'm going to go ahead and pull that pi out as well, because it kind of annoys me just sitting in there. So pulling the pi out of the integral, we're left with 64 minus, combining those fractions together will be 64/3 x, and then plus that 16/9 x squared on the end. We can do the antiderivative of each of these separately. So again, if you need extra practice with this antiderivative stuff, there is a practice in the homeworks there in MyLabs. So antiderivative of 64, that's just a constant, so we're just going to throw an x onto that. Antiderivative of 64/3 x, that's an x to the 1, which are going to raise up to be x squared, and then divide by that x squared. Or not by the x squared, sorry, divide by the 2. 64/3 cut in half is 32/3, and then that's x squared. Plus the last one, that 16/9 x squared, we're going to raise that up to be x cubed, and then divide by that 3. So now it's 16 over 27 x cubed, and this is going from 0 to 6. We might need some calculator help here. I'll go grab mine if I need to. So plugging 6 into all of this stuff is going to be kind of awful. Here we go. So 64 times 6 is 384, minus... another 384, kind of cool, plus the last one, $128. All right, so the 384s cancel each other out, and we just end up with that 128 pi. So just to double check to make sure we got it right, because I have gotten things wrong quite a bit in the past. 128 pi, yay, right? So that green check mark has got to be the most satisfying picture I've ever seen. Okay, I know I went through that one kind of quick, but I just wanted to show you like the process for these disk method questions. You're using the disk method formula, you're finding the formula for the radius of your slices and just plugging it in. Other than that, it's just a normal integral to go through. So is that one all right? Is there any questions about this stuff? Are we good? That's probably not a question a teacher should ask, right? Are we good? Any questions at all? Even if you don't have a question, at least put a no in chat so I know I'm not talking to myself.
Yeah, can you explain the 6 and 0? Like, where you got that from?
Yeah, so that's just going to be the limits of integration of the slices here. So if we're integrating along the x-axis, my slices, think of this like bread, right? And we're slicing this into a whole bunch of slices of bread. The slices exist along the x-axis from 0 to this point right here. For this question, I just counted, right? 1, 2, 3, 4, 5, 6. The other way of finding that would just be finding the x-intercept of the equation here. The x-intercept occurs when y is 0. So if I replace y to be 0, I get 4x is equal to 24. Then dividing the 4 over gives me x is 6 for that x-intercept. All right. Is that all right? Is there any other questions about this one? All right, great. Cool. Well, since this is just the first session, we'll probably just kind of end it here, unless you guys have any other questions from the homeworks.
I don't have a question. Can you hear me?
Yes.
Okay. I don't have a question from the homework, but for WebEx itself.
Yeah.
So I am logged into WebEx. Have the app downloaded. You know how to access these conference calls from that, because it's not showing up anywhere.
If you have WebEx downloaded, then whenever you click on the link to get into the meeting here, it should just automatically open up WebEx itself.
Okay.
Yeah, but
will you send out a link every time, or will we just use the same link?
No, I'll send out a link every time. So if you just want to check your email and just click on the link there. But when you have it on your computer or your phone and you click the link, it opens up it automatically.
Yeah.
All right, we got a request for number 6 here, so let's do this one real quick. We'll do this one and then we'll get out of here for sure. Find the volume of the solid generated by revolving the region enclosed by the triangle with these vertices about the y-axis. The volume of the solid generated is blah, 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 blah. Okay, so first things first is we actually need to kind of graph this and see what it looks like. So let me open up something that I can graph it. I was doing a lot of work earlier. Let me get a fresh page. Cool. Okay, so graphing these points out, and I'm not going to be able to do it perfectly because I'm on the computer here, but just a rough estimate of what they look like. So 3, 1 is going to be about there. 3, 6 is going to be way up here, and then 6, 6 way up here. So we're creating this triangle. All right, great. So that's my best graph that I could possibly make on this computer. Now we're going to be taking this and then revolving this around the y-axis. So we're actually revolving it this way. It's up to you which method you want to use here. This is very early in the homework, so I can already tell you that the method that they're going to be using is going to be with the washer method. We have to use the washer method for this one because the area that we're given is not bordering the axis of rotation here. All right, so I'm going to go back over to Word so I can type this up a little bit better. So once you've decided which method you're going to use, grab the formula from the formula sheet. For the washer method, the formula for the volume is the integral from A to B of pi, and then this gets a little bit complicated, but it's the outside radius squared minus the inside radius squared. And the outside radius and the inside radius should be inside of a parentheses. That pi is all the way on the outside of these two things. So pi, the outside radius squared minus the inside radius squared dx. Or, right, it could be with y's instead. In fact, this example is going to have to be with y's because we're revolving around a vertical axis here, around the y-axis. So my slices that I'm making are going to be slices with respect to y. Just to kind of blow up that triangle a little bit, what you want to do is you want to think about making like little bread slices of your image. So here we're going to make these horizontal slices, and then revolving that horizontal slice around this vertical axis is going to make a washer. So like a flat donut thing. Okay. Now, the hard part for this question is coming up with the inside and the outside radius. Like we already said, they have to be functions of y's because we're doing horizontal slices here. My outside radius is going to be the furthest distance from the axis of rotation. If the axis of rotation is the y-axis, then the outside radius is going to go all the way to this diagonal line for every single possible horizontal slice. We need to figure out what the equation of that diagonal line is. So we need the equation of the diagonal line. What we know about it is that it passes through two different points. It passes through the point 3,1 and then the point 6,6. Now you have to go back to like remedial math stuff to find the equation of a line as it goes through 2 points. So that comes from this formula. I hope this looks familiar. So y minus y1 is equal to m times x minus x1. That's called the point slope form. Yeah, point slope. So the first thing we're going to need to do is we're going to need to find that slope, the m value. That we get by just doing rise over run stuff. So it goes up 5 units, right, to get from 1 to 6. Then it goes over 3 units. So it's going to have a slope of 5/3. All right, and then we could use either one of those points. It doesn't matter if we use the 3,1 or the 6,6 for the x1, y1. I'll just use the 3,1. So we're going to do y minus the y of that point 1 is equal to the slope 5/3 x minus the x of that point 3. Now, you have to be even more careful now, right? Because we are revolving around a vertical axis, we're going to be integrating with respect to y's. As my slices move up and down, they are moving up and down the y-axis here. So I do not want to solve this for y. I actually want to solve this for x to make it a function of y. Let's distribute those 5/3 into the parentheses there. And then we're solving it for x. So I'm going to add that 5 over to the right-hand side. And then I want to divide everything by that 5/3, which is the same thing as multiplying by 3/5. All right, and we're here. All right, so I did that a little bit quick, but you're just solving it for x. I hope everybody's okay with algebra. Okay, this is the formula for that diagonal line on the outside part of our triangle, which means that this is going to be this outside radius here. As a function of y, the outside radius is 3/5 y plus 12/5. Great. We still need to find the inside radius as well. If, again, we're thinking about this as my horizontal slice, the inside radius is the shortest distance from the slice to the axis of rotation. That's going to be this inside distance here. This is just coming from this vertical line. And equations for vertical lines are real easy. My vertical line here has the equation x equals 3, since it's going to be intersecting there at the 3 on the x-axis. In other words, the radius is always going to have a distance of 3 for the inside radius. All right, and now that we have our inside and our outside radius and we have our formula, we just plug it in. So I'm going to get rid of all of this stuff. Just plugging it in, we're going to have the volume is the integral. We'll come up with the limits here in just a minute. Let's go ahead and write out our formula. So it's going to be the outside radius, 3/5 y plus 12/5 all squared, minus the inside radius, which is 3 squared. All of that is in a parentheses, and remember we are integrating with respect to y since we're revolving around a vertical axis here. All right, the limits. The limits are going to be where your horizontal slices exist. They exist inside of this triangle. This triangle on the y-axis starts here at a y value of 1. Remember, this was the point 3, 1, and goes up to this point, which was that point 3, 6. So because we're going from a y value 1 to a y value of 6, that is going to be the limits of my integral. All right, now the ugly part of actually doing this. So we'll FOIL that out and play around with it. I'll try to do it real quick. We're going to factor that pi out. Still have the integral from 1 to 6. 3/5, we're FOILing this, right? So 3/5 squared is 9/25 y squared. The inner and the outer is multiplying these two things together times 2. So these two things together would be 36/5, but there's two of them, so 72, or 36/25. So 72/25 y. That plus 12/5 times 12/5, which is 144 over 25. That's all going to be minus 3 squared, which is 9. All right, again, I'm not 100% sure I did all that in my head right, but I don't know, we'll go with it. So just FOILing this thing out, and then the 3 squared on the end. Combining those two constants together. I'm going to use my calculator. I'm not going to bother trying to do that in my head. I got negative 81/25. Great. Okay, so now just doing the antiderivative of each of these. Still have the pi on the outside. Antiderivative of 9/25 y squared. That y squared is going to raise up to y cubed, and we'll divide by 3. So now it's going to be 3/25 y cubed. The next one, we're going to raise that y up to y squared and divide. So 36/25 y squared. And then this 81/25 is just a constant, so we're just going to leave that and throw a y on it. Then we're evaluating this between 1 and 6. Calculator again, plug the 6 into all of that, and then minus plugging the 1 into all of that. I'll try and do it in my calculator here. If you guys have a calculator, try it on your own, see if you're getting the same thing. Alright, when I plug the 6 in, I got this really awful number. And there's a pi on this. That's going to be minus plugging the 1 into that. So minus, this came out to be negative 42 over 25 pi. And then adding these two things together, we just get 60. How cool is that? I was about to make like this big speech about how you're going to have to be really careful in this course because your answers are rarely ever going to come out to be very nice. Usually, if you get out a nice number, that means you did it wrong. But let's see if we did it right. 60 pi. Great. Okay, again, I know that I went through this integral kind of fast, but mainly because it's difficult to go through this slowly here, typing it all out in Word. I hope it's organized enough writing it out like this. If not, let me know and I'll try like a different thing than Word with writing all this stuff up. But as you can see, my handwriting's pretty bad, so not writing it up in Word may even be more difficult to read. But there we go. There's problem 6, completely worked out for you. Was there any questions about number 6 there? Is that all right now that you see it worked out?
Thank you.
You're welcome. Yes, I am. I'm recording this meeting, so yes, they'll be posted up on Moodle. I'm gonna have to make like a separate thing for it. I think I'm just gonna tack them down at the bottom. So these meetings, I'll change this up here to be WebEx meetings. So they'll be below the chapter content itself. Oh gosh. Computer's messing up some. WebEx meetings. Meeting recordings. Okay, great. Yeah, so I'll put that up. It takes a little while for it to like parse. I don't know exactly what the video editor does, but it takes a little while, so I usually let it run overnight, and then I post them in the mornings. So this will be up probably tomorrow morning. Any last questions about anything at all before we go? I do want to remind you that Thursday we're having another one of these at 1 p.m. I made one at night and then one during the day just because I know everybody has different work schedules. So I really, really highly encourage you to attend at least one of these each week, if not both of them each week. But if you can't make it to one of them, I totally get it, and it's not a big deal because I will be posting up the recordings. Also, I'm not going to see you guys again until Sunday, except for that meeting on Thursday. So I can't stress enough to work through as much of the homework as you can work through before this Thursday. That way, if you do struggle with something, you can ask it that Thursday before the homework is due the following Sunday. I'm also playing around a little bit with changing the due dates. Like maybe Sunday isn't going to work, and maybe the due date of being like Friday instead would be better. That way, it's a little bit closer to the meeting times. So I'll have to see how that's going to work out and see if it fits into my schedule. But we'll play around with that. Okay, anyway, I'm glad everybody made it. Thanks for coming to the first meeting. Welcome to Calc 2 Extreme. And I hopefully will see everybody on Thursday. So again, thanks for coming. Have a good night. See you guys later. Bye. Bye.